Hello to all my viewers, this is Dr. Dhaval Maheta. And today I will explain how to plot the lift chart in gradient boost tree in KNIME. So gradient boosting is a powerful machine learning algorithm used for both regression and classification problem. It is an ensemble method that combines multiple weak models to create a strong model. The basic idea behind gradient boosting is to sequentially add new models to the ensemble, each of which corrects the error made by the previous model. The final model is then a weighted sum of all the models in the ensemble. The algorithm starts with a simple model such as dysentery and trains it on the training data. The errors made by this model are then calculated and a new model is trained to correct these errors. This process is repeated iteratively with each new model focusing on the errors made by the previous models. Now you can see here we are having an original data set in which the algorithm has classified two cases, but there is some misclassification which has happened. Among the red dots there are blue dots, and among the blue dots there are red dots. Now, this misclassification which has happened, we will increase the weights of the misclassified observation. So this too, its weight will be increased, and in this the red dot, its weight will be increased. This will be iterated quite number of times till we get the final classifier, which in which the classification has been done accurately. So the final AOC is the ensemble of so many classifiers, and therefore it is known as an ensemble model. Confusion matrix we have already discussed in my previous video. In this video, we are going to generate the lift chart. A lift chart, also known as a gain chart, is a visualization tool used to evaluate the performance of the binary classification model, such as dysentery, logistic regression, naive Bayes, and support vector machine. The chart compares the predicted probability of the positive class against the actual proportion of positive instances in the dataset. Lift measures how our model is performing in prediction against the prediction without the model. So you can see here that if there are 10,000 cases, it will be divided into 10 parts. Each part consists of 10 percentage. So in the first part, out of 1000 cases, 876 events happen. So the total number of events which have happened is 3859. Now how to interpret this? So in the first part, out of 1000 observations, the number of events that occur are 876, which is 22.70 percentage of total events. 876 divided by 3859. The gain for the first part is 22.70 percentage, and the normal probability in this part is 10 percentage. The 100% probability has been divided into 10 parts, and therefore 10 parts, 10 percentage. In the second part, out of 1000 observations, the number of events that occur are 743, this one, which is 19.25 of the total events. The gain for the second part is 22.7 plus 19.25. The cumulative lift for the first part is 22.70 divided by 10 only, because it is only one part. So it is 2.27. And for the second part, it is 41.95. This figure divided by 20, because this is a two part. For the third part, it will be 55.79 divided by 30. And on that basis, the lift chart is generated. Now let's see how we can do this in KNIME. So for this, first of all, I'll activate the input output from here. Read CSV reader. I'll double click on it. I'll browse the dataset which is in CSV format. Art1, open, click OK. Right click on it and execute. Again, right click on it and you can see the file table. This dataset consists of heart disease. We want to do the prediction of heart disease on the basis of age, gender. Gender will not consider, age, resting blood pressure, cholesterol, and maximum hours of exercise. So we will have to filter it so that we can only consider those variables which are necessary for our model. Column filter, right click on it, configure. Take all the variables on the left hand side and take age, resting blood pressure, cholesterol, maximum hours of exercise, heart disease, click OK. Right click on it and execute. Again, right click on it and see the filtered table. Now all these variables are on different scales, and therefore it is necessary to normalize it. So I will activate the normalizer from here. Right click on it, configure. So normally we go for mean max normalization. Click OK, right click on it and execute. Now I'll activate the partitioning. The data will be divided into training and testing dataset. Configure. So 80% will be used for training purpose and remaining 20 for the testing purpose. The stratification will be done according to the hard digits. Right click on it and execute. Now I'll activate the gradient boost learner. Right click on it, configure. Make sure that the hard disease is the target variable. Click OK. Right click on it and execute. Now we'll activate gradient boost predictor from here. So this predictor will get its learning from here, but the data set will be from the partitioning. So it will be getting 20% of the testing data. Configure. Change prediction column name. Append. I'll just give the name probability pro. Okay. Right click on it. Execute. Again, right click on it and see the output data. So this is the prediction done according to the gradient boosting. And this is the actual data. Now let's see how well the classification is working. So for that purpose, I'll be using the scorer. Right click on it, configure, activate the hard disk, click OK, right click on it and execute. And you can see the confusion matrix. The classification accuracy has gone quite down 60%. 48 plus 64, 112 cases have been correctly classified. Now let's generate the lift chart. So I'll activate the lift chart from here. Right click on it, configure. Hard disk, here I'll activate yes. This is also yes. General plot options, create image at port, click OK. Right click on it and execute. Again, right click on it and see the image. Quite good. So for the first 10%, the lift is 1.5, the red line. Then it decreases to 1.21 or 22. After 65% of cases, the lift has gone down drastically. You can also generate the cumulative gain chart. Go in configure and activate so cumulative gain, click OK. Right click on it and execute. Again, right click on it and see the image. So this is a cumulative gain chart. So this is the way you can plot the lift chart using the gradient boost trees in KNIME. For more videos on KNIME, kindly subscribe to my channel. You can follow me on LinkedIn and Twitter. Please refer my playlist in which I already uploaded many videos on KNIME.